Right, lesson 11. In this lesson, we are going to discuss how to use the lookup function and data validation, and finally how to use statistical data analysis tool pack. So first we'll see and how to group the data. So here first we are going to discuss how to group data. Here you can see quarterly sales represented by this graph, year 2017, 2018, 2019 and 2020. So for 2017, 4 quarters are there. Then 2018, 4 quarters, 19 again 4 quarters, and 2020 another 4 quarters. So then two products displayed here, butter cake and fruit cake. The sales value, quantity of sales, number of butter cakes sold in 2017 quarter 1, 15,000. Butter cake, quantity of butter cake sold in 2017 quarter 2, 13,000. But if you want to find a specific year, for an example 2019, it's very difficult to read when it looks like. Therefore, we can use group function to display these things clearly. So what we have to do is we have to select all these data set and go to data, then click this group drop down arrow, then auto outline. Then it's grouped according to auto grouped according to the years. Now if you want to see 2019, then you can minimize these things and just you can look 2019. See 2019 quarter 1, quarter 2, quarter 3, quarter 4, but the total figures for 2020, 18 and 2017 also displayed here. So likewise you can group. If you want to ungroup this, what you have to do, you have to select this again and go to ungroup and click clear outline. Right, this is how we are use the group and ungroup function. Now we are going to see how to work with data validation. Here, create two columns as name and marks. Name and marks. So these are the two columns. Give data validation rule to marks that cannot enter the marks more than 100 for student. For an example, when you give a Excel sheet to enter the data for someone else, then you can put some validation criteria for these cells. Then he or she can't enter the data above or below your range. You can mention the criteria. Then the mistakes, you can reduce the mistakes that can happen while entering data. So for an example, here we are going to enter marks of this student for a subject. Then marks can be vary 0 to 100. It can't be more than 100. It can't be below 0. So if mistakenly, if someone entered here for 90, mistakenly someone can enter 900. 1 more 0. So it's a mistake. When if you have to enter marks of 500 students, these type of mistakes can be happen. Therefore, you can give a criteria for this cell range. First, you have to select this cell range and then go to data validation. Go to this cell range, then data validation and data validation. Click data validation. Here, it's asking any value. You can put whole number because you want to give a criteria. Then between 0 to minimum value can be 0 and maximum value can be 100. Then okay. Now see, can you mistakenly enter 101? No. Then it gives error message. It is not a valid number. So by giving data validation rule to a set of cells, you can minimize the mistakes that can happen while entering data. Right? So another example, give data create another 2 columns as name and telephone number and limit the telephone number to maximum 10 numbers. Also input a message. So now we are going to enter a person's telephone numbers. Therefore, we have to limit it to 10 numbers because sometime when we are entering 1,000 telephone numbers of 1,000 people, mistakenly we can add 1 or 2 numbers. Then the total telephone number will get wrong. Therefore, we can give a criteria, data validation criteria. So what we can do first, we have to, because this is a telephone number, this is not a number. Actually, we are entering telephone numbers as format cells, and you can give, if you want, you can use special, or else you can give text. Then click OK. Now I'm going to put the data validation rule. Data validation. Now not any value. Text length. I want to limit the telephone number to 10 digits, 10 characters. So not between, equal to length 10. Then if you want, you can put a message also. Input a message title. Telephone number. To the person who are going to enter the data, you can give a message. Please enter code number as well. And don't use any special characters. That mean hyphens, dash, don't use those special characters. So then this message will displayed here. Then the one who entered, he or she can read this and enter the data accordingly. Right. Click. Then error alert also you can create if you want. So if it is beyond 10 digits, you can give a error message. It can't be 9 numbers, it can't be 11 numbers. Telephone number should be 10 numbers, 10 digits. So you can give a title, wrong number. Then you can tell here telephone number should be 10 digits. Then click OK. Now see, when you are going to enter the data, the message will be displayed there. Telephone number, please enter code number as well, and don't use any special characters. So you know how to enter the number. And then when you are going to enter the number, I am entering first number, not 3422657778. Now it's okay. I'm going to enter another number. Mistakenly, I forget to enter the 0. 3422857789. Then what happened? Telephone number should be 10 digits. It gives a error message. So you know something wrong with the telephone number. So it's not allowed to enter this number because it's wrong. And it's still the telephone number should be 10 digits. So you know now if mistakenly you had entered below 10 or more than 10 digits. That's why it gives a error message. So you can correct it. By doing so, you can reduce the errors that can happen in the data entering process, right? Then we are going to check the statistical calculations here. In Excel, you can do statistical calculation as well as data validation. Here you can use lookup. For an example, this is the order numbers of a Pizza Hut and person who deal with that order. So order number 19,101 Jack, then 19,102 John. In that Pizza Hut, there are 5 or 6 people. They are supplying the orders. When they are supplying the orders with the order number, the name of that person is there. So 19,103 Christ, 19,104 Jackie, then 19,105 order. The Christ deal with that order. Therefore, this is a data set that displayed order numbers and who serve for that order. And there is an issue with the order number 19,112. So now it's telling there is an issue with order number 19,112. So find the salesperson who deal with that order. So we want to directly find the person. If it is a short list like this, we can manually find. But if it's a, for an example, think this is a telephone exchange service service supplying numbers, then more than 1,000 or 10,000 calls coming to that exchange to serve. Then they are putting a service number and their name. So from those 10,000 service numbers, if there is something wrong or if there is any complaint, you want to find who gave that service. Therefore, this lookup function will very much helpful in those instances. So now we'll try to find who supply the order number 19,112. So to do that, click order number. You can put it here because it's telling 19,112, the problem with that order, then order number, and then the sales person. We okay. So now you want to find the person who deals with this order. So to do that, you have to go to functions, formulas, and you have to check the function called lookup. Then the lookup function will be displayed here. You can select it and click OK. Then you have to select the first one, lookup value, lookup vector, and results vector. Click OK. Now lookup value. You are looking for this value. Then lookup vector. In which range you are looking for this value? In this range. Then the results vector. What is the result you need? the results you need from which range. You need the results from the name range. So you will have to select this one and then click OK. Then directly it will show the person. The Jack is the person who deal with the order number 19,112. So by doing so, you can use this lookup function to find a specific person who deals with the order. Right, now we'll see how to do statistical calculation in Excel. Normally, Excel, you can't do the statistical calculation. You have to use SPSS software, but in Excel also, by activating data analysis tool pack, you do statistical calculation. To activate the data analysis tool pack, you have to go to File, then Option, and then Add-ins. For the first time, this data analysis tool pack in the inactive application add-ins. Then you have to select that application and click OK. Then it will add to here, active application add-ins, right? So then it will display here in my Excel. I activated that analysis tool pack. So you have select analysis tool pack, not the analysis tool pack VBA, analysis tool pack, and then it will add here. Then click OK, and it will add to the activate applications. Now, after adding this data analysis tool pack, when you go to your menu item data, at last you will see data analysis, this tab. By using this tab, you can do so many statistical calculations. So here it gives name of few people and their height and weight. So it is asking find whether there is any correlation between the height and weight of the person by using data analysis tool pack and graph. So how to do by using data analysis tool pack? You have to click. You can select these two columns, height and weight, and you can go to data analysis. Here you can use correlation and click OK. Now it is asking the input range, then output range. You can select where you want the output. Click this one and give the output range here, then click here. And now if you have labels, that mean headings in your data set, then you have to tick on the labels in first row. If not, you can remove this tick, then click OK. Can you see? This is the correlation 0.95. That's a strong correlation because correlation is varied between -1 to +1. So if it is very near to +1, then it is a strong positive correlation. So person's weight and height have a strong positive correlation. Also, you can use regression to find the R-squared value. You have to read some statistical book. If you are no statistic, you know what is R-squared value. So we can select both these columns and then you can go to data analysis and then you can select regression and click OK. Now it is asking input range for X, input range for Y, right? Then do you have labels or not? We have labels. Then output range, I'll give here. Then it is asking what you need. You can tick if you want these things, or else you can keep as it is, and the confidence level. So normally we are set the confidence level to 95%. So then click OK. Now, can you see the R squared value is there? That means there is a positive strong correlation there, 0.88. Adjusted R square, standard error, number of observations, that means 15 people we check, everything displayed here. Regression, freedom, significance level, everything displayed here. So this is, you can check whether this figure is significant or not also. There is a strong correlation and it is significant because it is less than 0.001, because you have to put 7, you have to, this is E minus 0.07. That means this figure is equal to paste it and we'll explain this. Right. So anyhow, this is less than 0.001 and this is significant. So everything will be displayed here. Intercept, standard error, p-value, then lower 95% upper value, everything will be displayed here. Then if you want to find this correlation by using a graph, you can use, as I said earlier, you can use the scatter diagram. So select this one, go to insert, then scatter diagram, click poll type chart, then you can select scatter diagram, then click OK. Now you can see the scatter diagram. So if you want more details, what you can do is, I will show you, this is the scatter diagram. So if you want more details in relation to the correlation, you can go to layout and then you can activate these things. If you want, you can have the trend line. Then click drop down arrow and then click more trend line option. And then you can draw the trend line, linear trend line. And if you want, you can display the equation on the chart and display the R squared value of the chart. Then we can check these things and then click OK. Now, can you see the trend line displayed? It's a positive line and there is a positive strong relationship. The R squared value is 0.88. It is equal to this one. See, the R squared value is 0.88, 0.88. By using the graph also, you can search for the correlation. So it is correct because the both figures are equal. And now the equation also given here, y equal, that means student weight equal 0.9953, x mean the height minus 103. So by using this equation, we can forecast the figures. For an example, find the regression line to forecast the weight on height. So we find the regression line to forecast the weight on height. Then forecast the weight of 176 cm high person. So the height is 176. If a person's height is 176, what will be his weight? So what we have to do, y means weight. So weight equals 0.9953 into the height 176. We have to put a bracket here. Then minus 103.03. Then press enter. So this is the weight. If that person is, if that person's height is 176 centimeters, then his weight will be 72 kilograms. So very easily you can forecast the figures by using this equation. Then draw a histogram to represent the following data. It is asking now, you know, in statistics we can draw histograms. So to draw the histograms, we have to give the intervals. So there are 1, 2, 3, 4, 20 students. The marks are given. So we want to create histogram. The intervals are 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. We give 1, 2, 3, 4, 5, 6 intervals. So by using this one, we can create histograms. So first, by looking at the marks, you have to create the intervals. We are calling it as bins. So how to create histogram? You can select this. First, you can go to data, then statistical analysis, and then you can select histogram as the histogram. Then click OK. Now it's asking input range. What is the input range? So I'll select this is the input range. Then it is asking bin range. This is the bin range. Now it is asking whether you have labels. Yes, labels. We have labels. Now it's asking for the output range, where you want the output here. Click here. Then chart output, cumulative percentage, petro. So if you want, you can tick these things if you want these things. If not, click OK. Then it has created the histogram. See, the 6 intervals 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, like this, right? 0 to 20. This is the histogram. Right, this is the histogram. So if you want, you can draw a trend line here too. So you can do these things by using the data analysis toolpack very easily. Another one example, if you want to calculate the descriptive statistics, for an example, for this data, we can calculate the descriptive statistic. Descriptive statistic means mean, mode, and median, standard deviation, maximum value, minimum value, these kind of things. So in one shot, without giving so many formulas, you can at one shot you can calculate these things. First, you have to select this data set, and then you can go to data analysis, and select descriptive statistics here. Then click OK. Then it is asking input range, then labels. Yes, this is the input. This is the input range. Whether you have labels, yes, we have labels. Then output range, where you need the output, and put here the output. Then what you need, it is asking summary statistics, confidence level for mean, kth largest, kth smallest. I need just the summary statistics. Then click OK. Now can you see? Mean is there, standard error, median, mode, standard deviation, sample variation, Kurotis, skewness, range, minimum value, maximum value, sum, count. So everything is there. At one shot, all the descriptive statistic will be created by using this data analysis toolpack. You can create all the descriptive statistic for a data range in one shot. So this is how we are using the data analysis toolpack. So now you know how to use the data validation, then how to group, and then how to use the data analysis toolpack, and how to use lookup function in Excel.